Lesson 3.3 allows us to take a break from solving linear equations and converting it to inequalities. In this lesson, we'll graph systems of inequalities and learn where to shade the overall solution for the system. A system of linear inequalities can consist of two or more. Our plan will be to graph them individually, and the solution is where the inequalities overlap. Make sure to shade your solution clearly. Some students like to shade all of the individual inequalities and then darken in where the solution set is. Other students have found that they just shade the solution for the entire system. I'm fine either way. Just make sure that your boundaries are intact and that you're shading the appropriate area. Let's go ahead and try some examples. Graph each system of inequalities. In this first system, we're in great shape. We have y isolated on the left-hand side for both inequalities. I'm going to graph the first inequality in blue. Go ahead and pause the video and graph y is greater than negative 2x minus 5. I'm going to shade my overall region. If you don't want to shade that region yet, just press play when you're done and we'll make sure that we have the same boundary line. Here's my solution for y is greater than negative 2x minus 5. Notice I have a dashed boundary, and when I check 0, 0, 0 is in fact greater than negative 5. I shaded over on the right. I'm going to graph the next inequality in red. Please do the same. Graph your inequality and press play when you're done. Once both inequalities are graphed, you can see there's some overlap within our inequality system. Make sure to darken in that overlap clearly so that we know this is your final answer. And again, like I said, some students just shade that one region in without everything else. We'll just try not to go over those boundary lines. Maybe I should make that a little bit darker. Here we go. We'll just make sure that's darkened in. That would indicate that that is my final answer, which means any ordered pair in that darkened in region makes both inequalities true at the same time. Let's try the example on the right. 2x plus 3y is less than 6. The first thing we'd want to do is get y by itself in that first inequality. I'll move my 2x over, and that means 3y will be less than negative 2x plus 6. Whoops, got to get the plus in there. One step ahead of myself. And then if you divide both sides by 3, be careful on simplifying that right-hand side. Negative 2 over 3 would give you the slope, plus 6 over 3 gives you your y-intercept. I'll graph my first inequality in pink and then my second one in green. You go ahead and graph the system as well, and then press play when you're done, and we'll see what we get for our solution. Once my system was graphed, I noticed there is no overlap. The boundary lines are parallel and the shading goes in opposite directions. This would indicate that our system of inequalities has no solution. Anybody else having fun just kind of shading these graphs in? It's kind of tranquil. I'm enjoying it. Let's try some more. Our next system has 3 inequalities in it. I'm going to graph y is less than or equal to x in purple. Why don't you graph that one first? Let's just start with that first inequality, press play when you're done, and then we'll see if we get a match and we'll move on from there. I wanted to graph that inequality first since it goes through 0, 0. The slope is 1 and the y-intercept is 0. So the graph just kind of goes diagonally from left to right and it rises. Notice if we want less than or equal to, it would be the bottom half of that graph. Now let's go ahead and graph x is less than 2. I'm going to graph that one in orange. Oops, but I don't want to highlight it orange. I'm going to graph that one in orange. And then I'm going to graph 2x minus 3y is less than or equal to 3. Make sure to graph both of those and then press play, and we'll see what kind of region we get for our final solution. Taking a look at the orange inequality, x is less than 2. I have a dashed boundary vertical at 2. Less than would mean any x value that's lower than 2. I shaded on the left-hand side. For 2x minus 3y is less than or equal to 3, I had to get y by itself. Notice the direction for my inequality changed when I divided by negative 3. Looking carefully at the overlap, we have a teeny tiny triangle kind of with this boundary edge, this vertical boundary edge, and this kind of diagonal edge right here. So this shaded region, it's pretty small, would host all the ordered pairs that make all three inequalities true at the same time. All right, we have one more on this side. Let's take a look. We have a unique system here. Y is less than or equal to 3, and y is greater than absolute value x plus 4. Graph y is less than or equal to 3, and then graph the inequality for the absolute value. Make sure your absolute value is that V shape. This isn't a linear inequality. So let's go ahead and graph both of those, and then we'll be done with this side of our notes. For our final system of inequalities, we have y is less than or equal to 3, which is a horizontal line that's solid going through the y-axis at 3. Y is less than means any y value that's lower than 3. That means we shade below. For y is greater than absolute value of x plus 4, I noticed that would be a transformation of 4 units to the left from the parent function. I went -4, 0, there's my vertex, and went up 1 over 1 in both directions using a dashed boundary line. The overlap is just going to be the triangle that's kind of contained from that horizontal line and the bottom portion of the absolute value. So that should be the darkened in region for your solution. Any ordered pair in that shaded area makes both inequalities true at the same time. On the back, we'll look at given an inequality graph, writing the system, and we'll do that in class.